Good morning or good afternoon to everyone, depending on your time zone. Welcome to the Prevention and Epidemiology Committee. I'm Marian Newhouser, one of the co-chairs, and the other co-chair is Dr. Banu Arun. We are both very pleased to have everyone here today, even though we are not in person. Before we get started, I want to draw your attention to all the opportunities that you saw scrolling before we began the session today. And please do remember to support the Hope Foundation. Without their support, these opportunities would not happen. Next slide, please. Here's our agenda for today, which is quite full. I want to let everyone know that all lines are muted. For speakers, you will need to unmute your line when it's your turn to present your slides. For the audience, when you have questions for the speakers, please put them into the chat box, and Banu and I will monitor the questions and give the questions to each speaker at the end of each one of their presentations. All speakers will have their slides controlled centrally by IMS, so please give a verbal prompt to advance to each next slide on your presentations. So with that, I will turn it over to Banu, who will introduce our guest speaker for today.
Thank you, Marian. I also would like to welcome everyone to this year's virtual meeting, and we've heard that hopefully next time we will be face-to-face in the fall, so let's cross our fingers. Without further ado, I would like to introduce to you Dr. Scott Lipman, who will be our guest speaker today. He is the director of Moore's Cancer Center and is the PI for the NCI-designated Comprehensive Cancer Center on the P30. He is also Distinguished Professor of Medicine, Senior Associated Dean, and Associated Vice Chancellor, Cancer Research and Care at the University of California, San Diego School of Medicine. Dr. Lipman has led translational research as PI and investigator-initiated of high impact and definitive trials in lung, head and neck, and prostate, including the first precision medicine trials in head and neck prevention and lung cancer treatment. His research mainly currently focuses on precancer lesions as it relates to copy numbers and immunogenicity. He has published, as expected, in several high-impact journals such as New England Journal of Medicine, JAMA Oncology, Lancet Oncology, Cancer Cell, PNAS, and Nature Family, amongst many others. He has been funded as the PI by the NCI continuously since 1990 and has also other grants. He received numerous Prevention and Teen Science Awards, including from ACS, ASCO, AACR, and Stand Up of Cancer. He also chaired ASCO and AACR prevention committees and is member of several ASCO and AACR and other organization committees. And the list actually goes on and on. So it's really very long, as you can see, very, very, very well accomplished. Today, he will talk to us about precancer genome, immune interactions, and malignant transformation. Scott, welcome, and the floor is yours.
The whole group for this wonderful opportunity. So I'll talk about precancer biology, both genomics and immune mechanisms of interception, and particularly the interactions between genomic alterations and immune response or escape, and that's primarily genomic copy number alterations that I'll focus on. Next slide. So this is just a brief outline. I'll talk a little bit about genomic copy number alterations in precancer and cancer, mutational burden, immune response evasion, and a new initiative that is paralleling the TCGA, the Tumor Genome Atlas, and that's the Precancer Genome Atlas effort. Next slide. So this is a cartoon that excuse me, I borrowed from Teresa Davoli, who's been studying copy number alterations and their effects on a number of physiologic processes, in this case, immune. And it shows on the left it's just a cartoon of precancer, and then the multiple steps that can eventually lead to invasive cancer. And this process is under extensive study in precancer and starting to be better elucidated. But as I hope you'll see at the end, that I believe that that chromosomal or genome copy number alterations are a really important driver for many cancers, particularly head, neck, and lung, and head, neck is my major area. So I will say that if you look at the right, that copy number alteration, such as chromosome instability or aneuploidy, which is overall when we refer to aneuploidy or overall copy number, it's important to know that we're referring to a non-specific, if you look at the bottom right, a non-specific genomic event. So you can have high aneuploidy or copy number alterations levels, but you could get there by a lot of different ways. It's basically, based on the number of arms and lost and gained and things of this sort. So for this talk, it's really important to note that a lot of the studies that have been done with copy number have looked at non-specific alteration. And I'll just point out a semantic, a lot of fields have problems with, kind of the semantics of the terms. And those of you who follow this know that sometimes people use aneuploidy or generalized copy number alterations and chromosome instability as one and the same. And that is not true, but they are related. But there's important distinctions that we can get into. So we know that on the right, we know that aneuploidy is a common event. It's the most common genomic event in cancers by far, if you compare it to mutational processes, for instance. But we don't know as much about copy number alterations in precancer and their role. And I'll review, what we sort of know at this point. Next slide. So, two of the best studied precancers, other than head neck, which I'll talk about, that have looked at the role of copy number alteration in the transition from precancer to cancer. And again, these are non-specific copy number alterations called aneuploidy. And the two best studied are Barrett esophagus, which of course is a precursor to esophageal adenocarcinoma. It's worth noting that by far the premier center for the study of Barrett esophagus in the United States is in Seattle, as Marion knows. It's just an incredible program that began with Brian Reed and Carl O'Malley and others now. And this is from, on the left, this is data from one of their publications. And you can look at these SCNAs, stands for somatic copy number alterations. Again, it's a non-specific measure that if you look at the legend in the upper left, basically the higher the level of copy number alterations or aneuploidy, the higher the cancer risk. And you can see at this highest level, that light blue line shows the cancer rates, and to warn you, the horizontal axis is time in months, and the vertical is the cumulative probability of developing cancer. So you can see as you have higher and higher levels aneuploidy of instability, you have a higher rate of cancer. And again, there's a number of studies from the Hutch on this, and others have confirmed. On the right is a more recent study from Rebecca Fitzgerald group in UK, which is the other big group in this area. And they've looked at, you can see on the left, box plot CNA for copy number alteration, that if you look at Barrett esophagus lesions that progressed versus those that didn't, you see that the progressors to cancer, shown in orange, have a higher copy number alteration value on in median and overall than the blue non-progressors. And you don't have time to go into all this, but that box in the bottom left, for those of you who are interested, are two recent studies in lung cancer, the Teixeira's in squamous lung cancer precursors, and the one at the bottom of that is lung adenocarcinoma precursors. Two recent studies that focused on the role of copy number alterations in the development of copy number alterations in precancers and how that is associated with the risk of developing cancer. You know, I'm not going to mention now, but those of you who really know this area know that it's very difficult in some cases to determine risk. Like in lung adenocarcinoma, it's very difficult to follow prospectively in biopsy. So some of these studies are done cross-sectionally, and the surrogate for risk is comparing lesions of varying degrees of dysplasia, for instance, assuming mild dysplasia has a lower risk than severe, and so on. Others can be followed prospectively. And Barrett's is a great example of that. There's new technology that makes it fairly easy and reproducible to actually follow Barrett's esophagus, even though it's in the esophagus. There's some technology and device developed by Fitzgerald again that allows brushings of these, so you can actually follow patients prospectively. I'll just, give sort of my editorial 2 cents that I think one of the biggest challenges in this field, and I've been doing this for a long time, is the development of robust cohorts with longitudinal follow-up. I think that there's a lot of study introducing new technology that can be done in very small amounts of tissue, like single cell and high throughput assays. But again, it comes down to being able to apply those longitudinally and spatially to really get a good feel. Next slide. So what do we know about, so what I focused on is the association of these copy number alterations in cancer and the sort of the genomic effects that we see. This is now switching to the immune microenvironment effects. So switching gears completely. Now the question is, what do we see when you have a precancer, shown in the cartoon on the left, that develops into invasive cancer, independent of any kind of copy number or any kind of genomic event or omic event? What we do know from actually a number of different types of cancers, that when you compare the immune response, particularly the interferon gamma response signals in precancer, they tend to be much higher. So if you like to use the terms immune hot and cold, where immune hot would be lesions that have high interferon gamma levels and CD8 T cells, cytotoxic T cells, things like that. In precancer, you tend to see more immune hot, higher antigen presentation of gamma. But if you see the arrows and you then compare to corresponding invasive cancers, you see that there's a low response to interferon gamma, low cytotoxic cell infiltrate, antigen presentation, and so on. And I've put on the bottom left some, I think, really nice papers that and the fact that they're all pretty recent shows you, how much activity is going on in this field over the past, couple years compared to, decades before. So, these studies look at this process, not necessarily in a copy number way, just looking at the process of cross-sectionally looking at different grades of precancer, or in some cases following patients prospectively to see who develops cancer, and again, identifying that lower grade or tumors or lesions don't progress tend to be more immune hot than the cancers. Next slide. This is some related work on the left from Steve Dubinat at UCLA, published a year or two ago, I guess. And I don't have a pointer, but if you look at the Venn diagrams in the middle, and I'll talk about this in a minute, but there's sort of an overlap of mutational events that occur in precancer, that's the yellow circle, and those that occur in cancer in the red circle. And Steve is focused on that overlap, the mutations that occur in both precancer and cancer. And he has referred to those as progression-associated neoantigens, which he has data in lung adeno precursors to suggest that those are what drive the CD8 T cell infiltrates, as you can see in that black triangle type thing in the bottom. And again, he's looking at AAH, which is a precursor to lung adenocarcinoma, stands for atypical adenomous hyperplasia. And these PANs, these progression-associated neoantigens, seem to be associated on the bottom with immune resistance, increased CD8, and so on. And then on the right is another recent study. This one's on squamous. So the left was lung adenocarcinoma precursors. The right are lung squamous precursors. And you can see here that if you look at T cell infiltrate as a marker, for instance, and you look at the box plots, the blue are various grades of dysplasia that have regressed during longitudinal follow-up. And then the orange are the ones that had progressed to high grade or cancer. And what you see is that the green box, which are the lesions that regress spontaneously, have much higher cytotoxic T cell infiltrate in them. So again, sort of supporting this idea that immune surveillance or response is critical to whether precancers progress to cancer or actually regress on their own. So again, this is a concept that is just emerging. And the reason I'm showing you very recent studies is because, you know, these data in general are recent. I would say over the past 2 to 3 years, been a lot of interest in this. Next slide. So this is a slide that I borrowed from Teresa DeVoli from her science paper in 2017. It's on the left with a couple follow-on studies from other groups. But so this is looking, so now with that background, now we're looking at sort of the interaction between genomic copy number alterations in tumors and the immune microenvironment. So we're sort of putting it together now instead of sort of separately looking at one or the other. And, you know, again, without a pointer, it's hard to see, but, you know, on the box plots, you see SCNA at the bottom, which is, again, aneuploidy or copy number alteration, the horizontal, and then you see L and H for low and high. And the bottom line is that there are, you know, several cancers, probably most to some degree, have and you're looking at immune signature on the vertical axis. So cytotoxic immune signature, a measure of CD8 T cell infiltrates and others. But in any case, the bottom line is that you see that most of these tumors, that the H, the high, have a lower immune signature than the low. Meaning that high levels of aneuploidy are associated with immune cold tumors. And this has been shown now with, you know, again, NK and T cell infiltrates, cytotoxic T cell. But not all of them. If you look on the bottom right, you see that glioma, glioblastoma actually don't show them. Glioma is actually the opposite pattern. But the more common pattern is high levels of copy number alterations or immune cold in cancer. And the one thing that we actually joined forces with her in a really exciting collaboration. And the reason that it happened is that if you look at this and you look at the head and neck, which is the upper set of bar graphs, second to the left, head and neck cancer had actually, it was one of the 2 strongest signals of copy number alteration associated with immune cold. The other one was pancreatic cancer. So that really interested us. And then in the upper right, it's from the same DeVoli paper. This is from public data set of melanoma patients, which is in the upper right, that were treated with ipilimumab, so anti-CTLA-4 antibody therapy, immune checkpoint therapy. And what it showed is, again, this is, you know, in a retrospective analysis, is that that melanoma tumors that had high copy number alterations or aneuploidy, that's shown in red, had a worse outcome when given immune checkpoint inhibitor therapy, at least anti-CTLA-4. So I can just tell you that there are about 3, maybe 4 studies since this that have actually repeated this kind of finding, and that is there have been, with anti-CTLA-4, with anti-PD-L1, and actually studied with both that support the idea that high levels of copy number alterations, aneuploidy, are associated with a poor outcome with immune checkpoint inhibitors. So that it's fair to say that copy number alterations in cancer, in certain cancers, are probably one of the most important predictive markers of at least immune checkpoint inhibitor therapy, and maybe, again, there's been lung studies as well, and maybe, maybe other types of immunotherapy as well. We can go into this. It was a little tricky because of the prognostic effects, but this is clearly a predictive effect. So one of the biggest challenges in therapy of patients with most solid tumors, certainly head and neck, is that although immune checkpoint therapy has revolutionized and transformed the field, in head and neck cancer, 15% of patients benefit. And so predictive markers of efficacy or resistance are really important, and it's a real problem. This is one of the most promising ones. And the reason I'm saying here is that a lot of what we learn and look at in precancer is driven by what we understand from the cancer, and then trying to understand how they got there. Just an interesting thing that will come up about ways that precancer cells can escape the immune system. That's a big part of why pre-invasive lesions can transform to cancer. But interestingly enough, this Angelova paper studied colorectal cancer metastases, small number of patients, but really elegant study. And the bottom line is that metastases from colorectal cancer that persist or progress versus those that regress, which is uncommon, are the ones that progress are the least immunogenic, meaning that these metastases have figured out a way to evade the immune system. Very analogous to the precancer setting. Next slide. So go pretty quickly over some of these because those were the main concepts, but this is some earlier work on a retrospective cohort that we did with oral precancer. And, really the bottom line is we looked at it and came up with a gene expression signature that reflected immune active signature, and then one that was more classic. But the bottom line is, if you look in the right-hand graphs, patients that had loss of deletions at 17p13, which is where p53 is, you looked at if in the classical type where you don't see an active immune response, you see that deletion is associated with a high rate of cancer in dotted line. The bottom right is when you have this, copy number alteration, it's a focal alteration, and you have an immunologically active microenvironment, it basically diminishes greatly or eliminates the effect of this specific copy number alteration on cancer risk, suggesting that an active immune environment can keep these high-risk lesions with copy number alterations in check. Again, that's a hypothesis based on this. Next slide. Again, our area is mainly in head and neck, and one of the strongest predictors of risk in head and neck cancer is our copy number alterations, focal alterations, or loss of heterozygosity. And on the left is a study from Lee Mao out of our group, Ki Hunt's group, in, again, 1996, a long time ago, but basically was able to take patients who had precancer lesions in the oral cavity, for instance, and if they had focal deletion at chromosome 3p and or 9p, the orange, they had a much higher rate of cancer development, and that's the cancer-free survival on the vertical axis, time on the horizontal. Whereas if there was retention at both 3p and 9p, the rate of cancer was much lower, and you can see we're out to 100 months. This was confirmed in a study by Miriam Rosen on the right, about 9 years ago or so. Next slide. The interesting thing about this, and I'm going to leave for questions for those who are interested, is there's been a tremendous focus in the head and neck literature on chromosome 3p loss, 3p14, 3p21. And it's been a challenge because people have found that it's associated with cancer development and poor prognosis and a lot of work. But there's always been this issue that it's not clear there have been no tumor suppressor genes, for instance, that have been identified in chromosome 3p that could biologically account for this. And so in this study from Miriam Rosen with collaboration from Jack Lee at Anderson, and a large prospective and retrospective data set of patients with precancers, if you look at the left, which is a recursive partitioning model, when they looked at a number of different chromosomal sites, you see that the most important predictor of risk, the first sort of division in this recursive partitioning was 9p loss, if you can see that in the upper right. And then you go to 17p. The really unexpected finding here is that chromosome 3p loss dropped out completely of this analysis. So here we are, with 3p for whatever reason being a tremendous focus. And in this really definitive study, it completely dropped out. And the confusion was that when we reported this initial paper in 1996, we, for whatever reason, had come up with this metric that was 3p and or 9p loss. We didn't separate out 3p loss alone or 9p loss alone. This study was large enough to do that, and 3p went out, 9p turned out to be the pivotal one. I'll just say that in retrospect, probably the reason that 3p was reported to be associated with higher risk and even immune evasion probably has to do with the concordance of 3p loss with 9p loss. We found in the TCGA that patients that had 3p loss was strongly associated with 9p loss, or the other way around, so strong that the p-value was 10 to the negative 27. So I think that in retrospect, 3p was probably just acting as a surrogate for 9p in terms of the effects that we saw. Next slide. So this is more recent data looking at this, and you see the two Kaplan-Meier on the left. Just two different ways of looking at 9p loss in these precancers, and you can see that 9p loss was a much stronger predictor of cancer rates, with the vertical axis being probably oral OCSF, or oral cancer-free survival, and you see the red line. Whereas the 3p or 17p were sort of equivalent to no loss at all, no loss at these sites. And the strongest predictor of risk that we found was actually lesions that were dysplastic and had 9p21 loss. They were much stronger than no loss, and they were much stronger than 9p loss alone or dysplasia alone. And not going to comment a lot about this, but there's a lot of interest in this finding, at least our group, some others, because chromosome 9p, different than 3p, is incredibly rich for immune regulatory genes. It really is probably the most enriched area. You have CD274, which is PDL1. You have PDL2, you have JAK2, you have interferon alpha gene cluster, you have CDKN2A, all of which have been important in immune regulation. JAK2 is a very prominent interferon gamma pathway gene. So now we're finding these risks and other interactions on a region of the chromosome that has several potential culprits in the immune setting. Next slide. I just want to say that this is a study that was going on in Anderson. I understand that they stopped it early, and that it just didn't proceed well. But I put it up here because those of you oncologists use Pembro or Nivo quite a bit, no matter what tumor you treat, and compared to aggressive chemotherapy, it's better tolerated. I mean, it has side effects, no question, but they're different. So there's been a knee-jerk reaction to say, geez, if these PD-L1 inhibitors work, so well in cancer, and they're not all that toxic, maybe we can try it in precancer. And I remember talking to Jim Allison about that, who didn't buy that at all. But this idea of reverse migration, that you take what works in cancer and move it to precancer. I mean, it worked well for the tamoxifen model, but not a lot of others. And in fact, in oral precancer, you would predict that the high-risk lesions with 9p loss would not respond to PD-1 inhibitors because you've lost PD-L1 and PD-L2. So you can see how sort of this affects where you go. Next slide. And I think the slide, yeah. So this is a study from MD Anderson, a mouse model study, came out recently using a 4NQO model, which is a really good model for mimicking human oral cancer. And here you see, if you look at incidence of oral cancer, that CD40 agonists were by far the most potent in preventing oral cancer, actually more potent than combined anti-PD-1 and anti-CTLA-4. So again, just a cautionary thing that, just because it works in certain cancers, it may not apply to precancers for various reasons, as I mentioned. Next slide. So that was just sort of the main thing, just really quick on a couple Atlas projects, looking at an Atlas of immunity and of genomic progression. Next slide. Since the project we began in 2017, Ludmil Alexandrov, who we recruited right then, is leading this. He's a world-renowned cancer computational biologist. But it's just to show you, if you look at the left, you can see the number of cancers by cancer site in the GDC portal of tumors. On the left are the precancer samples that we've collected, and over these 4-year period, that have had either whole exome or whole genome sequencing, and we're over 2,000 samples in about 36 different precancer types, and you can see the organ sites here. So this has really been a major effort to try to develop this, this precancer atlas, which I think will be really useful for the field. But it's much more complicated, in my view, than the TCGA for various reasons, including the fact that, many people can't agree actually what certain precancers are and all these things. It's a very challenging field, much more now so than before. Next slide. And, these are the working groups, that have been created, that people have either sent in, specimens or are leaders in the field, and this continues to evolve and grow. And you can see, if you look on the left side under esophagus, working very closely with the Hutch on Barrett's. Next. And this is just to show, for those of you who are computational biologists, on the bottom left, you can see what we're talking about in terms of storing data on these many samples, currently with 346 terabytes, and that's turning out to be really expensive. But also just to illustrate the, what we all know, when we talk about esophageal cancer, we're talking about at least 2 different types, right? Squamous and adeno. Adeno being more common in US, for instance, and the precursors, Barrett's. On the bottom right, squamous carcinoma is more common in parts of Asia and so on, where squamous dysplasia is the precursor. Next slide. And so we're collaborating with a very large group in Asia about this. Next slide. Next. Okay, so again, just to give you an idea, show you some preliminary work. So you can see tumor mutational burdens on the left for esophageal cancer, squamous and adeno and their precursors. Really the main point here is to show some differences that you might expect. If you look on the right and you look at mutational signatures, the squamous precancer and cancer are driven by an APOVEC3B signature, whereas the Barrett's esophagus and adeno is not driven by APOVEC, but driven by signature 17, which, again, Ludmil Alexandrov has done this work and published an update in Nature recently with 100 different signatures. But signature 17 is one that no one knows what the actual etiology of this one is, but it is well characterized as a novel signature. Next. So you can click a couple more clicks of animation. Next, last one. So this is just to show, if you look at mutational landscape, comparing esophageal squamous cancer to precancer, you see a couple things. One, you see that, you see genes that are involved early and continually. This is related to the Steve Dubinet overlap mutational slide. And then you see late mutated genes, the PIK3CA, and you can see it there. I've marked it on the left next to P53, where it's low in precancer and much more common in cancer. And then you can actually see negatively selected genes like Notch1. In esophageal cancer, Notch1 mutations are much more common in precancer than in cancer. So again, given an idea that it's not linear, that mutations continue to increase, they have different roles and different time of the evolution. That's why these longitudinal studies are important. Next slide. And this is just, again, showing the APOBEC signature. If you look at an aging signature in squamous precancer versus cancer of the esophagus, it's similar. But if you look at the APOBEC signature, it's much more common in the cancer. Next slide. So this is, a lot of you are familiar with this bottom curve graph. This is actually a paper 2013 from Ludmil Alexandrov, which a lot of people use to talk about the role of tumor mutational burden as a predictive marker of benefit in with immune checkpoint inhibitors. And the FDA actually approved the immune checkpoint inhibitors across, I think, all tumors that have a greater than 10 cutoff. And this has come under a lot of scrutiny recently with a couple papers from Anderson and others that suggest that this probably isn't true. There may be some cancers that TMB above 10 is predictive. Certainly in the case of Lynch syndrome or colon, where you have MSI and really high mutational burden, it may play a role. But this one may have been jumped a little quickly because I think it's going to need to be changed. It's very clear now that mutational burden is not a very good predictor of immune checkpoint inhibitors in most cancers. Anyway, and then you can see on the top. So the top is the cancer. The bottom is using the same cutoff in a precancer, showing there are lesions that have a TMB above the cutoff that would be approved for FDA use of PD-1 inhibitors. But again, that's under study, under reevaluation in cancer. Next slide. Again, this is just showing graphically from Ludmil's group, showing that when you compare mutational burden in the precancer to cancer, and as you can see in the bottom graph, it tends to be higher in cancer, although there are some important exceptions. I don't know if you can see the colon adenoma one on the right. It's hard to, can't point to it, but in any case, you see that the cancer actually has a lower mutational burden than certain adenomas. Next slide. And then if you look at precancer, these are in adeno precursors and oral precancer with increasing grades. You tend to see with increasing grades in precancer that mutational burden tends to increase as you go from hyperplasia to dysplasia to cancer, similar in oral precancer, which is interesting. We don't know what to make of it, but that seems to be a pattern. Next slide. And interestingly, when you look at mutational burden, again, this is in precancer, on the left, you see that that in low risk, this is the far left, the low risk based on copy number alterations that I've just mentioned, the low risk lesions have a lower mutational burden than the high risk lesions. The middle box plot, the patients that develop cancer have a high median mutational burden than the ones that didn't. And if you look at the Kaplan-Meier, you can see the same thing, where in red are the lesions that had relatively lower mutational burden, and they did better in terms of cancer rates than those that had higher mutational burden. Again, this is all new and it's in precancer, not sure what it means, but it's not what you'd expect in cancer. So we'll see. Next slide. So finally, we're also including precancers, and just want to show the myeloproliferative neoplasms to make a point about stem cells, and then we'll be done. Next slide. So this work from a colleague of mine, Kat Jameson, and I think work that was recently published, but this is looking at mutational burden of MPN, so myeloproliferative neoplasia, which is a hematologic precursor to AML. And what's interesting, if you just go to the left, mutational burden, you can see that myeloproliferative cells on the right, on the clear one, have a much higher mutational burden than the NPM CD34 positive, which are myeloproliferative stem cells. So the stem cells in this precancer have a much lower mutational burden than the actual precancer cells. So again, the stem cell issues are going to be interesting to study. Next slide. So just in summary, I hope I've conveyed some of the work and interest in the role of immune surveillance, particularly in copy number driven early neoplasia. Probably play a pretty big role in preventing invasion. I didn't go into the detail, but in certain precancers, the actual copy number alteration that you see is very similar in precancer, high-grade precancer, than in cancer, which sort of tells you that it's probably not that kind of a genomic event that's going to be the key to transform from high-grade to invasive. And it looks like, mechanism immune escape could play a big role there. There are a lot of mechanisms of immune escape that are potential, some of them involving chemokine suppression and other JAK2 and others. I talked about building this precancer genome database, where it stands, and a little bit about some mutational burden signature studies we don't fully understand yet in precancer. And that, the idea that driver mutations can be higher in precancer than cancer is clear, not very common, but it clearly happens. And obviously there's implications on intervention. And again, I think it's these kinds of efforts, and there are others, that are elucidating the biology of precancer will be vital to driving early detection approaches with ctDNA and others, because the technology has gotten so great, but we don't really know what some of the findings that we find with this technology, what the biologic implications are. So that's, again, a big push for longitudinal cohorts. So I'll stop there and just, next slide, I think, has our group so far in the upper left is Ledmel Alexandrov. His lab is leading the PCGA, all the computational work. His grad student, Phoebe, he is the key point person, a lot of great students, and a list of collaborators that continues to increase. Is very collaborative, and you really want as much input as we can. It's a complicated challenge that we have for those who know precancer and the complexities of studying it. So I will stop there and be happy to take any questions. Thanks very much.
Thank you, Scott. This was wonderful. You did a great job in putting this complicated topic together. Especially, it's a little bit easier to follow in cancer and cancer management, but as it relates to precancer and prevention, it's very difficult. So thank you for that. While the audience is putting questions into the chat box, there's one question from Marian. When will the Precancer Atlas project be done, and how can other investigators use the data?
So I think that it's a project in evolution. I don't know that there'll be like a clear done point. I think that it'll continue to accrue patients. A lot of the patients' data we have are actually unpublished genomics data from collaborators, but we are planning on closing this initial data set in about 2 months to put together the first 2 papers or so on this project. But I envision that this project will continue to grow, with some of these, publications and others, and that we can develop a longitudinal component to it and add other layers, transcriptomics and other aspects. And so the initial reports will probably, start being put together in about 2 months. And as soon as those are done, of course, anything will be available to investigators to do this. But this is really a cross-sectional effort. kind of like the TCGA. Obviously, it's a baseline, and the thought is that people who are interested in certain PANNs or whatever may be interested in the database, and then adding on to it other types of molecular studies and longitudinal follow-up. So, when we first started doing this, and we had these 2,000 samples and involving precancers that I had never even heard of, and I've been doing this for 40 years. It's interesting, but anyway, and then people say, well, why? But we need longitudinal data. We need prospective follow-up, and transcriptomics, and of course, no question we do. But this is like, this is just the beginning, because again, as a lot of you know, there's just not a lot known for this. There's been an intense focus on cancer, and because of the complexities of precancer, technically, and others, I look at this as just part of an initial effort to kind of, get foundational data on various precancers. But I imagine this will be an ongoing event that continues to get more involved with single cell studies and other kinds of things layered on. Right now, we call it the Precancer Genome Atlas because it is entirely focused on the genome at the moment, but it's just the start.
Thank you. Dr. Neuhauser is making a comment saying that the atlas is very exciting and impressive. Since there are no other questions, I would like to ask the last question then. It's kind of, I think open-ended, obviously. So if copy number driven early neoplasia, if that is the driver, then do you think there's any role for immunomodulation at all? Can that change or reverse the process, or is it already too late?
No, I think that some data I didn't have time to show, what seems to be occurring in some cancers is that the relationship between certain copy number alterations and the immune microenvironment may actually switch. It may be different in precancer than cancer. The same genomic alterations, because again, in cancer, you have a much more genomically complex environment. You have other changes. You have P53 mutations. And so there seems to be this kind of switch where certain copy number alterations in precancer actually are recognized by the immune system. You see, increased T-cell infiltrates, kind of immune hot. And then you look at those same genomic alterations, let's say 9P, in cancer, and they're strikingly immune cold. So I think that my view now we know is in some precancer cancer transition, I feel pretty strongly about head and neck, at least oral cavity, there's actually a complete switch in the relationship between copy number precancer and cancer that occurs during this transition. And if we can understand what it is that drives that switch, what it is that makes it so that 9P or chromosome 7 is recognized by the immune system, immune hot and precancer, how do those cells then, with the same copy number alterations, then become immune cold, completely escape the immune system? What's happening to do that? And I think if we can understand that transition, that will, and mechanisms of immune escape, that will drive, I think, some really exciting interventions to basically stop or create some sort of barrier to that switch. But it's likely to be different in different tumors and think different precancers. But I think copy number alterations are not unusual in precancers. They just tend to be less complex, smaller size deletions, things of this sort. In fact, Ignacio Estuba at Anderson did some really elegant work in 2000. I think he published in Cancer Research a really detailed mapping study in lung tumors and looking at grades in resection specimens. And basically, the bottom line is that he found that 3P deletion, actually the size of the deletion increases as you go from mild, hyperplasia all the way to severe dysplasia. That 3P is involved all the way, but the deletion size increases and becomes discontinuous as you get into high-grade lesions. So your question is copy number too late? Is it, I think it really depends, because it's an evolving process, and focal focal copy number alteration, in certain cases may be more reversible and so on than if you progress to lose the whole arm in certain cases. So I think that the bottom line is I don't think it's too late. I think, we just need to understand the early copy number alterations and other genomic events and immune pathways to try to intercede. For instance, in head and neck, we find that cell-intrinsic SASP suppression seems to be a key part of the transition from precancer in the oral cavity to cancer. So I think understanding those pathways will be key. So.
Okay. Well, thank you so much. This was really very enlightening and motivating. Thank you for all of the work. I'm giving the floor now to Marian to continue with our agenda. Thank you, Scott, again.
Yeah, so thanks so much for inviting me. I'll drop off to my next Zoom, but
okay.
It was an honor to present to this group. Thanks so much. Bye.
Thank you, Scott.
Bye-bye.
Bye-bye.
Next slide, please. We'll now have a patient advocate update from Cheryl Jernigan. Cheryl, unmute yourself and the floor is yours.
I think I'm unmuted. Can you hear me okay?
Yeah, we can hear you, yes.
Okay, because when I tried to unmute earlier, it wasn't working. Oh, I meant to also turn on my video. Sorry. Well, shoot. Oh, there. Okay, there. Technology's all working now. We've actually been working on two things. So I'll tell you quickly about the SWOG Plain Language Initiative that we were working on with Wendy Lawton. And before she left, she shared with us the final copy and design for our website, swog.org. But I'm not really exactly sure when these changes will actually be launched. So stay tuned for what those are. But we're trying to have more plain, patient-friendly language and everything. Also, once a new writer is hired, we'll work with that person to begin developing plain language summaries for our trials and a social media kit. Now, regarding the informed consent document and process, we discovered many of us have concerns about and issues about how really informative the informed consent document and process are for most patients. And so we think the language could be improved to enhance patients' understanding and ability to truly make informed decisions. As a result, earlier this year, we started focusing on understanding what can we truly impact, because some of that language is dictated by NCI. In March, we surveyed our members and found out that we found out about how often and when our members are actually being asked to review the informed consent document in their committees and what kind of input they've had into the process and how they felt that went. We also discovered that most of us felt pretty confident in our ability to really review and suggest changes, but we all thought we could get more skills in this process, particularly in designing plain language and more patient-friendly language. And then we also don't always get the final consent prior to the trial's activation. And I haven't been around long enough to know whether that happens. Generally, I've seen the one that I've been involved in so far, but that's important that the patient advocate get the final informed consent document that was actually going to be used. Not surprising was that almost half of us were not really familiar with the NCI's document or the template. So based on our survey, we started focusing in April with our 2-hour meeting, which was April 1st, and invested time in getting to know what SWOG and NCI does in creating, reviewing, and improving the informed consent document. We heard from Dana Sparks, and she provided an overview of what SWOG's informed consent document and process for review are. She also gave us some insights on opportunities and timing and best practices for us as advocates as we're working on informed consent document development and review. Then we heard from Andrea Dinkoff, who heads up NCTN clinical trial operations, and she provided a brief overview of NCI's template, including its goals and was intended to achieve and how it was developed and updated. She reviewed the template's required language versus the recommended language, and what latitude we really had in editing the document for SWOG studies. She also described the consent review process once a NCTN group submits a protocol and consent to NCI, CTEP, and PIO. The exciting news for us as advocates that we learned from her is that the template, NCI's template's actually scheduled for review and update this year. And the last revision, as y'all are probably aware of, was in 2018. And the process was really complicated at that time. What I remember, a lot of stakeholders were involved, and it took quite a time period to get that review done. So our timing for wanting to improve the template couldn't be better. So in this past Monday's PAC meeting, with respect to our spring meeting, we discussed and worked through some case examples of actual SWOG studies. We delved into what plain language and patient-friendly language might look like. And we discussed how advocates can begin to assure that our documents and descriptions for SWOG are more patient-friendly, especially in those parts where we have some discretion as a study team. Our next steps are going to be to share the insights and suggestions we've gained thus far with both NCI and SWOG. And then we're going to keep working because, as you know, this is an ongoing process that's probably going to take some time. And we're going to stay with it to make sure that the language and revisions that we think are important are heard. Meantime, we will be working with our principal investigators on patient-friendly language and SWOG's documents, especially in the areas where we have discretion, and that starts with ensuring that the title for patients is patient-focused. So that's kind of the things that we've been really involved in recently. If you have any questions, I'd be happy to take them.
Great, Cheryl. That was a wonderful update. Lots of activity, and pleased especially to hear about the language updates. I don't see any questions in the chat, so I think we can move on. But again, thank you so much for being our patient advocate and all of your work on behalf of patients in clinical trials.
Enjoy working with you all.
Thank you. We're now going to move on. I'm going to turn it back over to Banu, and I will just mention that for those of you who are giving updates on active studies, we're running a little bit behind. So one way that we could perhaps speed things up is if you have a lot of background slides that we've seen before, you could skip over those or do them minimally.
All right, so next on our agenda is update from Dr. Jason Zell for the SOH20 study.
Okay, thanks. And yeah, I don't have a lot of background slides, and you've seen them before anyway. So this is PACES, preventing adenomas of the colon with the fluornithine and Selindac, the polyamine inhibitors. Next slide. I have two slides here. This one is the schema, and just to update everybody, so this is our phase 3 trial. There are now 2 arms as opposed to the original 4, and we've adjusted the numbers here to reflect, the final design. We will need 420 patients, 210 in each of the 2 arms, and we have accrued 242. So the trial is moving along. Our goal is 5 patients per month. Since the last SWOG meeting, I think we've averaged just 4 or just over 4. We always need to push more for, from sites. We still need help. This is a very important trial for the cancer prevention community, and we have an ability to make an impact. So please continue your efforts. I know it's tough to get patients on. Once they're on, the on study seems to go pretty well. And if this is a 3-year intervention. If you would look at the next slide, the endpoint is a rate of high-risk adenomas or second primary colon cancers. And here's just an update as of the most recent report of where we are in terms of demographics, stage, which is about what we wanted, half stage 3 and half under stage 3. So we're pretty close. And then the adverse events, mostly grade 1, and then some grade 2 with very grade 3 or 4 events. So with that, happy to take any questions, but those are our updates.
Thank you, Jason. Are there any questions for Dr. Zell from the panel or the audience? Well, thank you, Jason. I know it's a lot of hard work for years you've put on this, including the design change with the statistician and all of the approvals again.
Yeah, thank you. We're getting there though, so I am encouraged by that. Thanks, everybody.
Yeah, wonderful. I think I'll give the floor back to Dr. Neuhauser.
Thank you. Next slide, please. So now Dr. Nappy will give us an update on S1823.
Thank you. Thank you for the invitation. So I'm gonna give you an update about S1823, which is our prospective cohort study to validate microRNA 371 in patients with early stage germ cell tumor. So you have seen these slides before. So it's essentially to show that there are two clusters of microRNAs that are overexpressed in pediatric and adult germ cell tumors. And the next slide, please. These microRNAs are not only expressed by tumor tissue, but they are abundantly secreted in the blood, and we can detect them, and they are associated with tumor burden and with the stage of the disease. Next, please. We only need 200 microliters of plasma to detect these microRNAs. Next, please. Next again. And next. So after active treatment, we know that these microRNAs disappear from the blood, and the method we use currently to detect these microRNAs are commercially available. It's based on a real-time PCR, and the cost is very contained. It's around $60 per sample. Next slide, please. And based on our pilot study published in JCO in 2019, next, we have assessed that the occurrence of this microRNA, especially one of these microRNA cluster, microRNA 371, is very high, and it's higher than the CT scan and serum tumor markers. So where are we at in terms of validation of this biomarker? We do know that it's clinically and analytically valid, but we have to prove the clinical utility. And that this is the purpose of S1823, which will answer to the simple question of whether or not we can use this microRNA for the early detection of tumor relapse. So this is the design of the study. We have three risk groups, low, moderate, and high, based on the theoretical and expected risk of harboring active germ cell malignancy. Next. So in the low risk, we require blood to be collected every 6 months for at least 3 years in the no-relapsers, or until the relapse in the patients who are going to relapse with stage 1 or stage 2A disease. While in the moderate risk, because the risk of relapse is higher, we require the blood to be collected every 3 months. Next. Also, patients with high risk, meaning patients with obvious metastatic disease, can be enrolled and are eligible for this study. Obviously, the schedule of blood collection for those patients is slightly different because it's going to be pre and after active treatment. And as the active treatment, we will consider chemotherapy, but also radiation or surgery. Next, please. And also, this is very, I think, familiar to most of the people in this call, but it's essentially a very straightforward study. We only required additional Streck tube for blood collection, which will be sent to Nationwide for login and deposit. And then aliquots, when we plan the interim analysis, will be sent to Vancouver for the microRNA analysis. So the primary endpoint of the study is to establish the positive predictive value of microRNA 371 at the time of relapse. But I think more importantly, it's to assess whether or not we can use this microRNA soon after the diagnosis, after the orchiectomy, to predict the relapse. And As I mentioned, every patient with newly diagnosed germ cell tumor is eligible, stage 1 to 8, but also patients with more advanced disease. Next. And there will be a lot of relevant correlative questions that will be answered by this study: partners of care, quality of life, economics, comparative effectiveness, and the resources utilization, to mention some of these. Next. In terms of statistics, we are aiming to reach 50 relapses in patients with stage 1 seminoma and 100 in patients with stage 1 non-seminoma, but we also enroll patients with high risk. So the total number is almost 1,000 patients. And we do plan to do an interim analysis when for the relapse in seminoma and 15 non-seminoma will be reached. We are very, very happy about the enrollment of patients in this study. It was open at the end of July, and we have, as of April 12, under 32 patients enrolled, and the 334 approved sites. Next, please. This is a Canadian and US joint effort. The Canadian Cancer Trials Group has endorsed this study, and in fact, it's been open in Canada since August, and the first patient was enrolled in Victoria, British Columbia at the end of December 2020. Next, please. In terms of funds, we have the STAR funds from the Hope Foundation that will be covering the costs for the relapses samples analysis, which will answer to the primary endpoint. But as I mentioned, the longitudinal samples during the surveillance are extremely important to establish the predictive value of this biomarker when the tumor is not clinically evident yet. So we have applied for the R01, Part 19264 R01 grant, which is a biomarker and imaging integrated grant opportunity, and we got an exceptional outstanding score. Obviously, we don't know about the funds yet because the percentiles are not being released, but we will know in August. We are also looking at other funding opportunities, especially Department of Defense grants, which has established a specific germ cell tumor grant opportunity this year. Next, please. Next. I think that's my last slide. Thank you very much.
Are there any questions for Dr. Nappi? Congratulations, first of all, on the very good accrual to the study so far, and also congratulations on the potential R01 funding to continue to support this study. It's very exciting. Any questions for Dr. Nappi? Okay, it seems like everything is going very smoothly. And again, congratulations and thank you for sharing this great update. So,
thank you.
Banu?
All right, can we have the next slide, please? So the next presentation will be by Kathy Cruz, S1904.
Can you all hear me? Yes, good. So just as a reminder, S1904 is a cluster randomized controlled trial testing web-based decision support tools for breast cancer chemoprevention. So we plan to enroll a total of 26 sites who will be cluster randomized to either the intervention arm of the RealRisk and BNAV web-based tools, plus standard educational materials versus standard educational materials alone. And we're targeting women who are high risk for breast cancer based upon a diagnosis of atypical hyperplasia or lobular carcinoma in situ. And our primary endpoint is to look at chemoprevention informed choice, which is a patient-reported outcome after their 6-month follow-up visit. And secondarily, we'll look at other PROs as well as actual chemoprevention usage and adherence, reasons for discontinuation. We also have an implementation aim to see how these web-based tools are being used in the clinical setting. So the trial was officially activated in September of 2020. Next slide. And Thus far, we have 21 of our target of 26 sites recruited and recruitment centers that have been randomized. So they're listed here. And that means we only have about 5 more sites left to complete the, to get all of the 26 recruitment centers on board. Next slide. And because this is a multi-level intervention, we're also, it includes a provider intervention. So we plan to accrue a total of 200 providers. As of last week, we had 70 providers enrolled across the first 13 recruitment centers. The other recruitment centers are gradually getting onboarded right now. And that's the tally from the different sites who've been very active in recruiting providers. Next slide. And this is some baseline data from the first 63 providers that have been enrolled thus far. So it's predominantly women, about half are medical oncologists and a quarter are surgeons, although we do have some internists and family practitioners as well. That's the racial ethnic background. And this is a group that's pretty well versed in breast cancer risk assessment, and over 80% of them have prescribed anti-estrogen therapy for chemo prevention. Next slide. As part of our implementation aim, so for the providers who are randomized to a intervention site, we're also doing baseline interviews. So we've recruited already half of the total of 30 provider interviews thus far, and our goal is to get anywhere between 2 to 4 providers for these baseline interviews at each of the intervention sites. So those are the sites that have providers enrolled in the interview study thus far. Next slide. And then our patient recruitment is so after we get the recruitment centers and recruit the providers, then we recruit the patients. As of last week, we had 22 patients enrolled. I think I heard this week we're up to 25. So recruitment of patients is gradually picking up. And so we're pretty close to hitting our recruitment target. Next slide. So our goal is, like I said, we only have about 5 more recruitment centers left to enroll. So if we can complete that, get all the sites on board by summer of 2021, and then have all of our providers enrolled by the end of this year. And then our goal is to recruit anywhere between 13 to 15 patients per month once all 26 sites are onboarded. And we hope to complete that over the next 2.5 years. I think the last slide. So some potential early publications thus far. We've been working on a study protocol manuscript, and we hoped once we get all 26 recruitment centers identified, then it'd be worthwhile to submit that manuscript. And then we do plan to have an initial mixed methods paper, which includes the 30 baseline interviews of providers. And then once we have all the providers enrolled, hopefully by the end of this year, we can also include their survey data. And we've been holding monthly calls with the recruitment center sites, the coordinators, just to maintain engagement, get feedback from the sites in terms of what's going on and how can we help facilitate accrual of both the patients and providers. And so we hope to get them engaged scientifically as well. And some of those site PIs and key stakeholders can also serve as co-authors on these publications. I think that's it. Yep. So any questions, you can also contact us at swog1904@cumc.columbia.edu. Thank you.
Thank you, Kathy. It's really great to hear that despite COVID, everything is going well. It's a miracle. Everything was on a standstill, and you opened in September, right? You know, after COVID. So that's great. Do we have any questions from the panel or the audience for Kathy? All right, looks like there are none. So, Marion?
Thank you, Kathy. Next slide, please. So now Dr. Deirdre Hill is going to give us an update on the National Myelodysplastic syndrome natural history study. Deirdre?
Hi, thank you for the opportunity to provide an update regarding the MDS syndrome study. This is NCT 277-5383. Next slide, please. A brief overview of the study objectives and scientific questions. The objectives of this study are to enroll participants with myelodysplastic syndromes or cytopenias of undetermined significance and to follow them longitudinally, collecting serial blood samples and creating a biorepository with link to clinical data. The overall goal is to facilitate biomarker and other risk factor investigations that will be high impact for MDS patients. Next slide, please. An understanding of MDS natural history is really essential to inform etiology and prevention, as up to 30% or more of MDS will transform to acute myeloid leukemia, and percentages are even higher over a longer follow-up period. This study fits well in the theme of precancerous conditions as presented by Scott Littman earlier in our session today. The study aims to facilitate discovery of biomarkers and other risk factors for progression to AML. In addition, the goals include to improve diagnosis and classification, as there are gray areas, to define the optimal use of existing therapies, and to identify new therapeutic agents. I want to add that creation of a robust cohort with a biobank linked to clinical data for use by investigators is rare, and it's sometimes a thankless task. And this study is really poised to address some vital questions, as you can see here, regarding etiology and prevention, and I believe it's really worthy of our support. Next slide. Patients who are eligible for the study, briefly, are those with suspected MDS or myeloproliferative neoplasms, MPN, who are undergoing diagnostic workup, or those who have developed MDS in the prior 12 months, and patients cannot have been treated for MDS, or they cannot have a recent diagnosis of hematologic cancer. Next slide. Let's review the study status. Next slide. Despite the fact that enrollment got off to a rather slow start in this study, it is now 95% of that projected overall, as depicted here in yellow. The time period of study hiatus due to COVID is in the window on the slide here in early mid-2020. Next, please. We can see under monthly rate that the accrual has been averaging 20 to 30 or a little more during the COVID era, with 1,314 participants enrolled at present. The study goal is 1,750 enrollees. The expectation is that this study will remain open for probably 36 months. Next slide, please. Over time, SWOG has logged a bit behind other NCT and cooperative groups in enrollment. We have found that this is not because SWOG is not enrolling, but because SWOG sites are crediting the enrollment elsewhere. We would like to see more enrollment with credits to SWOG if possible. Next slide, please. Very briefly, the study investigators have a renewed emphasis on minority recruitment. Next slide. Overall, only 8% of the participants in the study are minorities, but for MDS, only 3% are minorities, while minorities constitute 9% of MDS in SEER or NACER. So the steering committee would like to engage with investigators and sites that can facilitate minority recruitment. And if that is you in this audience, we would like to hear from you. Let's skip the next slide. And let's skip the slide after. And let's skip one more. And we'll just finish up one more by talking about the fact that the study has published 2 descriptions of the resources that are available, listed here at the top, and had submitted 2 abstracts to ASH, including one that addresses one of the study questions about misclassification of MDS diagnosis. Next slide. And finally, gratefulness and acknowledgement of the investigators' advisory groups that make the study possible, with thanks to both NHLBI and NCI for funding.
Great,
you.
thank you. Thank you so much for that terrific update. I have one question. You mentioned that there's going to be some biomarker discovery work done, and I'm wondering if there are any specific biomarkers being considered yet.
The ASH abstracts have some biomarkers that were included, and so those are moving to publication soon. There have been some whole exome sequencing in the study. There have been targeted sequencing. So there is quite a bit of work ongoing, and there is opportunity for much more.
Great. So we'll keep our eyes peeled for those publications. Thank you. I don't see any other questions in the chat, so I'll turn it back over to Banu.
All right, thank you, Marianne. So can I have the next slide? It will be a verbal update by myself related to S1418, because I had shown the slides and background multiple times during this meeting. As you know, S1418 is the adjuvant pembrolizumab versus placebo study for triple-negative high-risk breast cancer, either high risk or residual disease after neoadjuvant chemotherapy. And the amendment we proposed was looking at breast density changes in patients receiving pembrolizumab versus placebo over a year. So before start of pembro mammograms will be compared to the patient's standard mammograms that will be done a year after. So it's a retrospective review. The main study is going through several prolonged amendments, and once they are through and approved, the next amendment will be the mammogram amendment that is, I think, next on the list, which we were told will happen in April. So there's still a few days. I'm hoping to give you a more progressed update during the next meeting. Any questions for me? If not, Marianne, I think we can continue with the next two new studies.
Next slide, please. So Dr. Connolly will now present an update on 2003.
Okay. Can you hear me? Thanks.
Yes, yes, sounds great, Eileen.
Okay, great. So this is an update for my study SWOG-2003, which is a phase 2 study to evaluate local recurrence following intraoperative radiation for DCS after breast-conserving surgery. The study was designed to look at local failure, defined as local recurrence in the lumpectomy bed within 2 centimeters of either DCS or invasive disease from the day of surgery out 5 years. And the hypothesis is that radiation, intraoperative radiation, would be better than surgery alone compared to historical data using the ECOG 5194 data cohort. Next. The secondary outcomes were included patient-reported outcomes regarding cosmesis. This was also designed as a feasibility study to determine if a randomized study would be possible. And then we were looking at both patient-reported outcomes with toxicity as well as physician-reported toxicity outcomes, and a translational aim of looking at the biomarker, the Decision RT tool, which is an immunohistochemistry-based assessment of about 20 different genes, proteins actually expressed on the cells that is predictive for local recurrence in DCIS. Next slide. So briefly, I've discussed this a million times. The background, we all know DCIS is a treatment challenge because with better screening, we find more of it. And there is a significant concern that we're over-treating it because while radiation does reduce local recurrence, there is no survival benefit with radiation. So there's a question of can we scale back the radiation treatment? And intraoperative radiation is an attractive alternative because this is done in the operating room at the time of the lumpectomy, and it's very convenient for the patients. The reported outcomes from the target trial, which was using low energy photons, is that it's non-inferior to whole breast irradiation. The initial results of the Elliott trial were non-inferior, though the 10-year outcome actually now is inferior in early invasive disease, but that's a different modality. And it is cost effective for early invasive disease. And so ASTRO guidelines for partial breast irradiation did allow inclusion of DCAS for partial breast irradiation, which interop is a form of, though it does make the caveat that intraoperative radiation should only be offered as part of a prospective registry or clinical trial. So next slide. So the initial study design that we presented to the NCI in February is as such. It was a single-arm, non-randomized phase 2 study. We enrolled low-risk patients defined as women 40 and older with lesions less than 2.5 centimeters in size at grade 1 and 2, less than 1 centimeters in size at grade 3. They had to be unifocal, screen detected. We did not specify if they were ER/PR positive or negative, and they had to be amenable to breast conserving surgery. All patients would undergo surgery with intraoperative radiation. Post-operatively, they would be risk stratified based on their post-operative risk features, which is determined from final pathology, meaning how large the mass was, what grade it was, and what the margin status was. And this could put patients into 3 categories: suitable, cautionary, or unsuitable risk. These are defined by the ASTRO consensus guidelines. And the suitable and cautionary risks are those for which partial breast irradiation is thought to be a reasonable option, and those were going to be followed for 5 years to look at local recurrence. The unsuitable risk are patients who are found postoperatively to have high risk features for which whole breast radiation would be recommended. And those would have been followed for secondary outcomes such as cosmetic outcome and as well as the translational outcome. All patients were proposed to get breast conserving surgery with radiation. It would have been with either one of 2 different devices that deliver low energy X-rays, Zoft or Zeiss systems, which are comparable. Post pathology determines risk stratification, and if radiation, whole breast radiation was recommended, it would be a standard 3-week course, given about 8 to 12 weeks after. And FFPE blocks were to be collected for the translational aim. Next slide. So where we stood at the last meeting is this had been triage approved in October of 2019. We spent some time getting commitment for support, both from industry. Prelude has supported the translational aims. Zeiss and Zoft are supportive of the study. The translational aim was approved in May of last year. Financial feasibility was determined. We worked with IROC quite extensively to determine credentialing guidelines. And finally, we were able to present to DCP in February of 2021, at which point it was disapproved. So the next slide goes through their concerns. Next slide. Okay. So their summary, this is a summary of the concerns. I think the largest concern they had was the design. They did not like the single arm design with a historical control. I think that was the largest amount of feedback that we received. There was also some feedback based on recently published partial breast radiation studies that included DCIS, that it's not published yet, but from the lead investigator, they communicated that grade 3 DCIS or ER negative DCIS may be unsuitable for partial breast irradiation. There was a signal there that maybe there was a higher rate of recurrence. So they were concerned about that as well. They wanted us to stratify based on ER/PR status as well as endocrine therapy use. And they wanted the definition of recurrence to be similar to what was used in the more recent APBI studies. So any in-breast tumor recurrence. They were concerned about the fact that by including the cautionary risk patients, those that are between the ages of 40 and 50, who maybe have grade 3 disease, we'd have a higher percentage of patients who needed whole breast radiation afterwards, and they wanted us to minimize that. They also really, I think, wanted a study that compared IORT to surgery alone. I think the fundamental question, and I think this was from their disapproval summary, and I've heard this elsewhere, is that people really want to answer the question is intraoperative radiation better than breast surgery alone? And they thought it was a missed opportunity if we didn't specifically focus on that. And they wanted to look at the Decision RT tool as well in that question. So we redesigned it. I can go to the next slide, which sort of shows the redesign that I worked on with the stats people, with Kathy, which now we're limiting the patients that are eligible to the very lowest risk patients, those that are 50 and older, again, screen detected unifocal, but only grade 1 or 2. They must be hormone receptor positive, and again, operable. And in this case, so these are all preoperatively suitable, and they would be randomized to surgery alone or surgery with intraoperative radiation. Post-operatively, they would be, again, we would look at their post-operative risk. There is the potential that patients would have high-risk features that you don't detect preoperatively. We could find grade 3 disease. It could be bigger than we expect. In that case, those patients might be recommended whole breast irradiation, but they would still be included in the analysis for the group with which they were originally randomized. And the primary outcome, the other thing that was brought up is they thought that for DCIS, you really need to look at a 10-year local recurrence outcome. So that would be changed to look at 10-year local recurrence as the primary outcome. Again, hormonal therapy would be offered. It's not required, though I think the goal would be to collect data on who started it and whether they were able to continue it. And then the decision RT, again, we would want to do this as a translational aim where tissue is collected, the test is performed, but the results are not given to the patients or recruiting physicians because we don't want them to change management. And the idea is to look at how well it predicts those that who do not maybe need radiation. And so basically, the next step, next slide. The design, so the study assumptions, the initial thought we had was to use local recurrence rate, estimate local recurrence rate for surgery alone of 12% versus intraoperative radiation of 4%. This is based on the ECOG Akron trial, which included the very low risk patients, exactly matching what we're defining them as in cohort 1. And in that trial, they found that the recurrence rate at 10 years was 12%. However, only 30% of the patients in that trial who completed 5 years of tamoxifen. A parallel study performed at the same time period was the RTOG 9804. This study only enrolled low-risk patients, which again match our entry criteria. However, they did initially require hormonal therapy. Ultimately, they had to make it optional because they had low recruitment due to the fact that initially it was required. But at the end of the study, what they found is they had 70% of their patients complete 5 years of endocrine therapy. And their local recurrence at 10 years is reported in surgery alone. The surgery alone arm was 9%. With whole breast irradiation, which was the randomization in that trial, it was 1.7%. So if we use 12%, we would require 450 patients on the trial to be randomized, which is 225 per arm. This assumes that 10% of patients are lost at 10 years, as well as 10% of patients would have an increase in risk and might potentially get additional therapy. Because we wanted to leave enough patients that had the intention to treat, meaning they did not get whole breast radiation, to prove whether or not IORT is better than surgery alone, but still include the cohort of patients who would get additional radiation. And we estimate it would be 3 years of accrual and 7 years of follow-up. And this is with 80% statistical power and one-sided alpha of 0.05. If we change the 10-year event rate for surgery alone to 10%, then the numbers do go up. It's 678, which is still reasonable, but this was part of the questions that I had in terms of what numbers we should choose. I did present this to the radiation oncology section on Tuesday. The feedback I received there was a bit of a leaning towards the lower number of 10% because they felt like that would be, you could defend it robustly, that we would not expect anything lower than that in the surgery alone arm. Next. So that's where we are. My goal is to, after receiving feedback today, revise the study concept so that we can go back to DCP as quickly as possible. So I did see one question in the box, which is why 50 and older is used as not postmenopausal. I think we could make postmenopausal. I don't know if that would make it more difficult for recruitment. 50 was sort of meant as a catch-all for postmenopausal, and in the APBI guidelines, suitable risk is defined as 50 and older, and it's probably for that reason. But are there any thoughts on that? As far as screening, so the question is, will screening with breast imaging be standardized for both arms? We wanted standardized, we did not want to require additional screening, meaning MRI imaging preoperatively. We wanted to leave it to the surgeon's choice. However, all patients, I imagine, would undergo standard mammograms.
Okay, and there's one more question, Eileen, and that is, how will you know whether to use the estimated event rate of 10% or 12%? Because presumably it will need to be based on some data. So how will you know which event rate to use?
Well, that's why I was presenting both of those trials, because I think they're the best, that is the best data available to estimate the surgery alone event rate. The only significant difference between the two studies is really the usage of tamoxifen. Those trials were performed in exactly the same period. They opened in 1999 and both closed around 2006 or 2007. So they're sort of very similar. From the literature, it seems like hormonal therapy usage is slightly lower. I know I've talked to Benno about this, but it's maybe probably 50% is realistic. But, you know, you could argue to say the lower or choose 10% because then that's sort of a conservative number. Regarding preoperative MRIs, for DCIS, you don't typically see that used. Most surgeons, I don't think we should require it because I think that would actually dissuade people from enrolling because one, I think we'd have to cover the cost, which would completely increase the cost of the trial. And I don't think insurance will routinely pay for it. Generally, screen detected DCIS is due to calcifications, which are mammogram. You can see on mammograms. So there isn't much of a role for the MRI.
That makes sense.
Yeah, I don't know if Bannon has anything to say. That's the breast imaging.
No, I was just asking and hoping to hear that it's usually not done so that, you know, we are not concerned about introducing yet another, you know, imaging modality that many people would use, but some don't. But if many don't use it, kind of related to Kathy's question, that's good.
Yeah, and actually what I found is when you look based on age, if MRI is used, it's more often in premenopausal women because they tend to have denser breasts, and there's always that concern you're missing a cult. But in postmenopausal, much less usage.
Great, that's a very good rationale. So any final questions for Eileen?
This is Kathy. I was just wondering, a statistician who has been working on this, we could maybe even build into the study, taking a look with the DSM, see sort of what the prevalence is of the hormonal therapy. And if it looks high, then we say that we would increase the sample size. So we wouldn't have to actually look at endpoints, but we would just look at the characterization of the women who are going on and what their pattern of use is. And if it looks higher than what we projected, we'll go with a larger sample size. That might be an option that we could just sort of have the rule built in.
Oh, I see. So then perhaps we could propose 12%, but then pay attention to it and maybe increase the number, or would you?
Right. I mean, you know, like start at 12%, and then it might have to drop to a 10%, right? And then increase the sample size. We could talk about it more offline. I'm just throwing it out there as part of a roadmap we could specify.
Yeah, no, that makes sense. Now for the concept resubmission, I mean, I know one other thing that was proposed is that I submit sort of what the total patient numbers would be for 12%, 11%, 10, sort of give them the range of patients required.
Yeah. Well, I think we can paint the whole picture for them, but talk about maybe some rules we might want to specify.
Okay, that makes sense.
I think that's an excellent idea.
Yeah. And then the other thing I thought would be nice is you had talked to me about a futility. Even though we would have fully accrued, if we knew at 5 years that IORT was no better than surgery alone, I guess you end the study essentially, not do further follow-up. Would that be how that works?
Yeah, I mean, if we feel comfortable that 5 year is a good reflection of what we would expect at 10 year, that if we're not seeing an improvement at 5 year, you know, make certain assumptions since 10 year is the endpoint that people were most interested in. But if we don't see any difference, that we're seeing fewer recurrences, then I think that is an argument for having a futility analysis at that point.
Okay.
We can see what they say.
Yeah. Okay.
Great, Eileen, I think you've gotten some really good feedback, and we'll continue to get feedback, from the committee as time goes on before this gets submitted again. So thank you. Thank you, everyone, for those great suggestions. So I'm going to turn it back over to Banu for our last presentation.
Yeah. Thank you. May I have the next slide, please? And the next study in planning will be presented by Dr. Julia McGuinness.
Hi, everyone. I met some of you at the monthly call earlier this month, but for those who don't know me, I'm currently a third-year medical oncology fellow at Columbia, but will be joining the faculty as a breast oncologist in July. And so today it's less a presentation of details of projects and more about background for and rationale for some of the studies we're proposing, and that we now have the green light for from other committees. So next slide. So as everyone here knows, 5 years of anti-estrogen chemo prevention is quite effective at reducing the risk of invasive breast cancer by at least 50% amongst women who are at high risk for breast cancer. But a major barrier to uptake and adherence is side effects. And while investigations of de-escalated strategies, including lower doses of chemo prevention, are ongoing, there's a clear need also for tools to assess response to chemo prevention while patients are on therapy. Next slide. So one such tool to assess response is a pharmacodynamic biomarker that captures dynamic changes while a patient is on endocrine therapy. So in women at high risk for invasive breast cancer, a pharmacodynamic biomarker could provide short-term assessment of response and inform chemo prevention treatment decisions, such as changing classes of anti-estrogen therapies or changing doses of a medication from higher to lower or the other way. But thinking more broadly, chemo prevention treatment trials take years of follow-up and large sample sizes to report long-term clinical outcomes, such as incidence of invasive cancer. And so a biomarker could serve as a surrogate for these long-term clinical outcomes in trials, which could improve efficiency, reduce costs, and potentially lead to more rapid drug development. Next slide. So imaging-based biomarkers, as I'm sure everyone here are aware, are attractive candidates for biomarkers of response in this high-risk population, because women at high risk for breast cancer standardly undergo annual screening mammography. There's already precedence for this, obviously, with mammographic density and changes in mammographic density at short term, at 1 year, predicting invasive breast cancer. But the use of mammographic density is limited by its dependence on radiologists' interpretation, with variability between reads by the same and other radiologists. So one possible way to overcome the limitations of visual interpretation of breast images is using deep learning. So for this audience, to just briefly review the terminology surrounding deep learning and artificial intelligence. So the most general category is artificial intelligence, which broadly describes the ability of a machine to accomplish tasks typically associated with intelligent human behavior. Within that category is machine learning, which refers to computer algorithms that learn how to map input data to an output prediction. These algorithms are designed such that greater exposure to data results in more refinement through self-adjustment. And then a further subset in machine learning is deep learning, or artificial neural networks, which process information in a manner inspired by the neurons in the human brain, that is through complex and interconnected layers of analysis. The specific subtype that I'll be referring to today is convolutional neural networks, which are used specifically for image processing. And these work by passing pixels from an image through multiple layers of data filters and analyzing them in complex layers of analysis. And the whole process is independent of any human interpretation, fully automated, and can be applied to existing images with an output that's a prediction or a probability. Next slide. So here at Columbia, we've developed a convolutional neural network-based model that is applied to digital mammograms and provides a predicted breast cancer risk score on a continuous scale from 0 to 1, as well as heat maps demonstrating areas of risk in the breast. So just to illustrate, here are mammograms from 2 patients with similar breast density on the left in the typical mammogram, but different CNN scores, which you can see visually with higher areas of risk denoted in the breast by red and lower by blue-green. So in order to create this algorithm in an initial training set, we identified 737 women at average risk for breast cancer who had presented for screening mammography at Columbia, of whom 210 ultimately developed breast cancer. We applied our CNN model retrospectively to digital mammograms obtained at least 2 years prior to cancer diagnosis if it occurred, and recorded mammographic density for comparison. And what we found was that our CNN model was a better independent predictor of breast cancer risk than mammographic density, and also had an overall accuracy of 72% in predicting breast cancer cases from the initial non-diagnostic mammogram. Next slide. We next evaluated if the CNN model could show changes in predicted risk among patients who receive endocrine therapy for chemo prevention. So shown here is results from a cohort of 720 women who had high-risk breast lesions at Columbia, of whom 240 received chemo prevention. And we again retrospectively applied the CNN model to their mammograms at baseline before treatment and then at 3 to 5 years later to assess for change. And what we found shown here is that women who received chemo prevention had a greater decrease in CNN score over time, which was consistent with the known benefits of chemo prevention, and also demonstrated that the model is modifiable with endocrine therapy. Next slide. So just to give you guys a more visual representation of such changes, here are images from the contralateral breasts of 2 patients with ductal carcinoma in situ who did and did not receive tamoxifen, with mammographic images on the top for each and then CNN images on the bottom. Just to note, as with mammographic density in this population, we only apply the model to the contralateral breast to avoid any confounding changes from any surgery biopsies the patient might have had. So images A and C for each patient represent baseline, and then B and D represent follow-up at 3 to 5 years. And what you can see is that there are clear visual changes in the CNN images for the patient who received tamoxifen with decreased intensity of the previous hot spots that you can see at follow-up, but the patient who did not take tamoxifen did not have much change. Next slide. We've also recently applied the CNN model to mammograms among women with early stage hormone receptor positive breast cancer who had serial mammograms and received adjuvant endocrine therapy, with the goal of evaluating if the model could be a pharmacodynamic biomarker of response to endocrine therapy in this setting, and also predict breast cancer relapse. And shown here is the CNN scores over time stratified by relapse being in red, no relapse being in blue. And you can see that CNN scores were consistently higher in the relapse group. And in particular, looking at the short-term change from 0 to 1 year, change in CNN score during this timeline was significantly different between the groups who relapsed versus did not relapse, with a decrease seen among those who remained in remission, but minimal change among those who relapsed. And in Cox regression analysis, change in CNN score at 1 year was significantly associated with breast cancer-free interval, even after we adjusted for known prognostic factors. Next slide. So given our promising retrospective data, we now plan to validate our findings using prospective data sets. First, by retrospectively applying the model to breast imaging collected as part of prospective adjuvant clinical trials at SWOG, and then also by potentially incorporating the model into the design of future prospective treatment trials. So I'll highlight some of our work with SWOG that's all planned, some of which is in various stages of development or implementation, to give you a sense of where we're going next with some of this. So next slide. So first, starting with a retrospective application of the model to prospectively obtained images. And So SWOG conducted, or rather S0812 investigated the potential use of vitamin D as a chemopreventive therapy among high-risk premenopausal women. And women were randomized to 12 months of vitamin D, 10,000 units per week, or placebo. The primary endpoint here was change in mammographic density at 12 months as quantified using Cumulus, which is a semi-automated method of measuring mammographic density. And while vitamin D did not show a statistically significantly greater change in mammographic density than placebo, so it didn't meet the endpoint, we hypothesized that because the CNN model evaluates mammographic features beyond density, we might be able to show significant change at 1 year by applying our model to the mammograms obtained. And so we therefore plan to apply the model to mammograms obtained as part of this trial at baseline 1 and 2 years to essentially assess for change with placebo versus vitamin D, and also compare to change in mammographic density, which is collected as part of this. You can see that there were 80 patients in the vitamin D arm and 69 in the placebo arm with evaluable mammograms at 1 year. And we already have approval to conduct this analysis. This will be moving forward. Next slide. So as was already presented, S1904 is ongoing and is evaluating web-based decision support tools and their effect on chemoprevention-informed choice. But as part of this, a secondary outcome is chemoprevention uptake and adherence. So there will be data collected on this. And so given that this study will follow women prospectively for up to 5 years and also capture chemoprevention usage, we plan to propose an amendment in the next weeks to months to obtain annual mammograms from the patients enrolled in this study, basically with the goal of comparing change in CNN score over time among patients, but particularly at 1 year, and looking specifically at differences between those who end up receiving chemoprevention and those who do not, to sort of further validate or explore the findings that we had in a retrospective data set. Next slide. The caveat with this slide is this is very much still in progress in the extremely early stages, and so I wouldn't take the details on this slide as anything close to being final. But the basic idea of a proposed study of alternate dosing of exemestane in DCIS is sort of along the lines of de-escalation that are being proposed, obviously, in other trials, including Dr. Connolly's. And particularly here to evaluate a potential de-escalation strategy of lower dose aromatase inhibitor in patients with DCIS, similar to the strategy with low dose tamoxifen, with the hypothesis that lower doses will have similar efficacy as full dose. Again, this is extremely in progress, but we hope to also incorporate the CNN mammographic evaluation to evaluate annual changes in scores with chemoprevention and also compare the changes among the arms. So you'll be hearing more about this in future calls as we further develop the proposal. Next slide. And then just to also mention the work that we are going to be doing in the adjuvant setting with endocrine therapy. So I'm sure as everyone or most are aware, S107 or 1007 or R-exponder enrolled women with early stage hormone receptor positive HER2 negative breast cancer with 1 to 3 positive lymph nodes who had an Oncotype DX recurrence score of 25 or lower, and evaluated endocrine therapy alone versus chemoendocrine therapy in this population. The results were presented this December at San Antonio and particularly demonstrate that we can use Oncotype DX among postmenopausal women to potentially, with 1 to 3 lymph nodes, to potentially guide decisions about adjuvant chemotherapy. But for the purposes of validation of our CNN model as a biomarker of response to adjuvant endocrine therapy, S1007 provides a great opportunity to apply our algorithm to prospectively obtain breast imaging in patients with long-term follow-up, including documentation of clinical outcomes. And so we'll be moving ahead with this analysis more for the adjuvant setting, but also in the larger goal of further validating our algorithms. Next slide. So in conclusion, the CNN model applied to breast imaging might be a pharmacodynamic biomarker of response to endocrine therapy, potentially both in the chemoprevention and adjuvant settings. And so we now plan to validate our findings using prospectively obtained imaging and also by potentially incorporating into prospective trials within SWOG, such as the exemestane study we're proposing. And if our hypothesis is correct that the model is a pharmacodynamic biomarker of response, it could be used to guide chemoprevention treatment decisions and could also be used as a surrogate for long-term outcomes in clinical trials. Next slide. So obviously the strengths include that it addresses an unmet clinical need using a novel automated technology and overcoming a lot of the limitations of visual interpretation of images. It also doesn't require any additional testing for patients in terms of biomarkers, but the limitations potentially are obviously related to the nature of the algorithms themselves. We have noted what we would call interbatch variability in CNN scores, so running different groups, it does seem to be some variability. But given that the nature of the algorithms is to self-adjust and actually improve with repeated exposure to data, we expect that with application to the various data sets in these studies and other data sets, including imaging from other machines, that it will improve. The other, of course, with artificial intelligence is the issue of the black box of what exactly is being incorporated into these algorithms. We have an idea that something like mammographic density is being incorporated, but we have no way of confirming that. So next slide. So this is just acknowledgements to the rest of our study team. You obviously all know Dr. Crew, but then from radiology in SWOG is Dr. Richard Ha, and then the rest are from Columbia and other institutions. So I'll end there and see if there are any questions. Again, it was more just an introduction to this technology, to maybe get some ideas going about future proposals through SWOG.
Thank you, Julia. So we have only 2 hours left to finish our allocated time, but this is a very interesting topic and has significant prospective applications, as you indicated, in incorporating that in our prospective breast prevention trials. Any questions or feedback for Julia? I don't see any questions, but well, it looks like none, and we are almost at the hour. I would like to thank everyone for joining us and for your questions, for your attention. And again, as mentioned, hope to see you all back in 6 months. Not virtually, but face to face. So I'll give the floor to Marian so that she can also do her closing.
Yes, thank you everyone for joining us today. I know it's been a long week of a lot of WebEx calls and presentations for the SWOG group meeting. But thank you everyone, and thank you especially to the investigators who presented their ideas today and gave updates. And also thank you to our patient advocate, Cheryl Jernigan, and our protocol coordinator, Patricia O'Kane, who we keep very busy. So thank you to everyone. And as Banu said, we hope to see everyone in person in Chicago. And in the meantime, please stay safe and healthy. Bye now.
Bye.